Well, good evening there. We've got another great topic on derivatives here, and this one's called derivative of the inverse. So let's start by taking a walk down memory lane and just reminding ourselves about inverses. So go ahead and jot these down. Properties of inverse functions that you should be aware of. First of all, the notation for inverse is this is f to the negative 1 of x. It's read f inverse. The notation used to represent the inverse of a function. So here's property number 1, composition. If I compose f of f inverse of x, I should get x. And likewise, if I go backwards, if I compose f inverse of f of x, I should get x. So I picked two functions, and we'll just practice with these two. I picked f of x equals e to the x, and g of x equals ln of x. And we're going to go ahead and compose those two functions. So let's start with, this will be, I'll call this one my f inverse. So I'm going to put f inverse into f. So I'm going to take the ln of x and put it into this x. So I would get e to the ln of x. And now I know e and ln are inverses, and you'll see I'm just left with x. Remember, inverses, they cancel each other out, so to speak, to 1. So I have 1x. Now let's take f of x and put it into f inverse. So I'm going to take e to the x and put it into the ln of x. So I would get the ln of e to the x. Again, those are inverses, and I'm left with just x. Since this worked out in both directions, I know that these two are inverses. Property number 2. The domain of f of x is the range of f inverse, and the range of f inverse is the domain of f. So let's go ahead and on your two pictures, let's just quickly state the domain and range. The domain here of e to the x, so domain is x values, it goes from negative to positive infinity. Sorry, my pen is really dying on me here. My range are my y values, so it goes from, looks like a height of 0 up to infinity. Now my domain on my ln of x, notice it goes from 0 to infinity. And the range, my y values, go from negative to positive infinity. So we can look at that property and say, yeah, that is true. The domain on e is now the range on the inverse, and the range on f of x is now the domain on the inverse. So that property does hold true. Let's go ahead and fill this table, and we'll pick a few values. Let's say we pick 0, 1, and 2. So, and we'll title this graph f of x equals e to the x. All right, so I'm just going to substitute in 0. I'm going to get e to the 0, which is 1. E to the first is e. E squared is just e squared. Don't try to put a number in place of e. Now, on the second graph, we'll call this g of x equals the ln of x, and we'll do the same thing. But what I'm going to do is switch the x and the y, because that's what an inverse is. So I'm going to take these y values and put them into my x values. 1 e and e squared. So now when I take the ln of 1, picture that graph, the ln of 1 is 0. The ln of e squared, those are inverses, I should get 2. Oops, I jumped the gun there. The ln of e are inverses, they cancel, they don't disappear to thin air, they give me a 1 when they cancel. And then I just did that ln of e squared, I should get 2. So let's take a look at property number 3. If f of x contains the point AB, then the inverse should contain the point BA. And that's what I kind of just showed you in this table. If 0, 1 is a point on f of x, then its inverse should be 1, 0. 1e should be e1, 2e squared, e squared 2. And now the second part is kind of more of the calculus definition. The slope at the point AB is the reciprocal at the slope of f inverse. So let's go ahead and get our slopes. If f of x equals e to the f prime of x, the derivative of e to the u is e to the u times du, so times 1. So I should get a slope of 1 e and e squared. Because again, I'm just substituting these numbers into my derivative, which was the exact same thing as the function. Now, let's go ahead and take the derivative of the ln of x, g prime of x. That's du over u. My u is x, its derivative is 1. So again, I'm going to plug in my x values. 1 over 1 is 1. This becomes 1 over e, and this becomes 1 over e squared. So you can see that that holds true as well. The slope at f of x, the slope of f of x at the point AB, and its inverse should be the reciprocal of that. All right, so what's it going to look like on the AP? So that was a quick review of inverses. The derivative of an inverse, here's your definition. If f of x and g of x are inverse functions at the point AB, and the point AB is on the graph of f, then here's the rule. The derivative of f inverse is 1 over f prime of f inverse of x. So I'm not going to do too many examples, but I think these are worth writing out in your notebook. So example 1. The functions f and g are differentiable, and f of g of x equals x. This is huge. Okay, they almost never say derivative of the inverse. You have to recognize that this means inverses. And that's why we spent the few moments in the beginning going over that. When they compose f of g of x and get x, they're telling you that these two functions are inverses. If f of 2 equals 10 and f prime of 2 equals 8, find g of 10 and g prime of 10. So here's the first thing I do. I make a note that they're talking about function f here and they're giving me the point 2, 10. And now they're telling me that f and g are inverses. So that means on the graph of g, I automatically know the point is 10, 2, because they're inverses and we just literally switch the a and the b, the x and the y. So this value that says find g of 10, bam, that's done. G of 10 equals 2. Because they're inverses, we're just switching the x and y. Now, to get that derivative, I'm going to memorize that formula. 1 over f prime of f inverse of x. So here's what I say to myself. Plug in the number that they want. They want g prime of 10. So I'm going to plug in the number 10. 1 over f prime of f inverse of 10. Okay, now, we already know f inverse of 10 right from here because f and g are inverses. The inverse of 10 is 2. Now watch your notation. This is now 1 over, I'm replacing that section with a 2. 1 over f prime of 2. Now typically they give you that information. If I go back and look, f prime of 2 equals 8. So this becomes 1 over 8. And there you have it. Derivative of the inverse. All right, example 2. And again, let's copy this down. We're only going to do a couple examples. Let f be the function defined by f of x equals e to the 3x minus x squared plus 5, and g equals f inverse. G of 6 equals 0. What is the value of g prime of 0? So I want you to box this in. This is the key. Okay, and you're going to see what I mean in a moment. First, that does tell you that they are inverses. Okay, but this is the main key. So here's what we're going to do. We're going to set up the formula. The second I see inverse, I know it's 1 over f prime of f inverse of x. Okay, and I'm going to replace the x with whatever number they tell me to. So 1 over f prime of f inverse of 6. Okay, now notice they didn't give me the f function, but here's what they did. Use this key. I want f inverse of 6, and the key says g of x equals f inverse of x. So if I want f inverse of 6, that's the same thing as g of 6. I'm using this key. If I want f inverse of x, f inverse of 6, that's the same thing as g of 6. So in this case, I'm saying, okay, this is 1 over f prime of g of 6, which is 0 from the directions. Okay, now I need to take the derivative of f and plug in 0. They didn't give it to me, so I'm going to take it by hand. So if f of x equals e to the 3x minus x squared plus 3, and I derive it, remember that's e to the u du. So e to the u is e to the 3x times its du, so times 3, minus 2x. And then I have to carefully plug in a 0. Well, what's nice is 2 times 0 is 0, so that's gone. E to the 3 times 0 is e to the 0 times 3. Anybody to the 0 is 1, so I basically get 3. So I'm going to get 1 over 3 for my final answer. F is a differential function given by f of 2 equals 5, f of 5 equals 14, f prime of 2 equals negative 7, f prime of 5 equals negative 5. And here's the key. They're differentiable, and right here, they are inverses. So again, it's not going to say it in plain English for you. You've got to read that notation. So the question is, what is the value of g prime of 5? All right, so I'm going to start with my notation. 1 over f prime of f inverse of x. And I'm going to plug in the first value they want, of 5. So 1 over f prime of f inverse of 5. Okay, now I need to plug 5 into the inverse. So another way to think about it is you're plugging 5 into the y value instead of the x value. Maybe let's make a note of that. When you plug into the inverse, you're going to plug into the y value. So if I look at f of 2 is 5, therefore f inverse of 5 is 2. So if f contains the point 2,5, the inverse would be the point 5, 2. So I'm going to say this is 1 over f prime of 2. And now I don't have to take the derivative because they were nice enough to give it to me. F prime of 2 is negative 7. Now you'll notice there's a lot of extra information in here, and they're trying to mess with you. They don't want you to think that f inverse of 5 is 14. They want you to understand that when you take an inverse, you're plugging into the y value. All right, f be the function, f of x equals ln of x plus 5. F and g are inverses. You're highlighting that for yourself and starring it. You're going to use that at some point. What is the value of g prime of 8? So 1 over f prime of f inverse of x. That's 1 over f prime of f inverse of 8. So I need to plug 8 into the inverse. Now notice they didn't give me anything. What the heck am I going to do with that? There's no random point they gave me. I have to solve this for myself. So again, I want you to star this. When you plug into the inverse, you're plugging into the y value. So we have to figure out our own x value. So I'm going to say, okay, here's my function. I have to plug 8 into y to get the inverse. So 8 equals the ln of x plus 5. All right, subtract 5, subtract 5. 3 equals the ln of x. How the heck are you going to solve that equation? Well, you're going to use your exponential rules. You're going to exponentiate both sides. E raised to the 3, e raised to the ln of x. Exponentiate is what we call that. These are inverses, so I get x equals e to the third. So now I can replace 1 over f prime with e to the third. Okay, so now it says take the derivative and plug in e to the third. So now I have to go back and take the derivative of f of x. So f of x equals the ln of x plus 5. Its derivative. Now notice there are no parentheses, so it's not the ln of x plus 5, it's just the ln of x and then a random plus 5. So I'm going to say f prime of x equals du over u. My u is x, its derivative is 1. The derivative of 5 disappears. So I'm going to get 1 over e cubed. Now be real careful when you plug that in. So I'm going to get 1 over e cubed, which of course you can think of it as keep, change, flip. And I'm going to say that final answer then is just e cubed. All right, last example here. Copy this table down, and it says f inverse is the inverse of f. Write an equation of the tangent line to f inverse at x equals 1. So to me, the big question is what point is on the inverse of f? What point is actually on the inverse of f? And I'm going to keep going back to the idea that if you want to find a value on the inverse, you're going to plug the number into y to find an inverse value. So what I'm going to do is I'm going to say, okay, let the value be 1, but I'm going to plug it into the y column. So when y is 1, the output I get is 3. So I'm going to say on this inverse function, the point 1, 3 lies on the inverse. Okay, and that goes back to the past couple examples we keep talking about. You're going to plug the number into y to get the output value when you want an inverse. So 1, 3 lies on the inverse. And now I think it's pretty straightforward. We're just going to use that formula again. 1 over f prime of f inverse of 1. And I've identified the point on the inverse as 1, 3, so I know this is going to become a 3. And now I just need f prime of 3. So I'm going to go to when x equals 3. I'm going to go to f prime, and I'm going to say they meet at -2. So I'm going to get a 1 over -2. Now I'm not done until I put that equation together. So I'm going to say that's y minus 3 equals -1 over 2 times x minus 1. And just a quick reminder, if I wanted the normal line to that, I would flip and negate that. So I would say that's y minus 3 equals positive 2 times x minus 1. So that's my tangent line and my normal line. Lastly, the other trick I say to myself, and I don't know if this will help anyone, f prime of f inverse of x, if I ever get stuck on which order do they go in, I think of the number pi for prime first, then inverse. So a little trick to kind of help you remember the order. Pi, prime, inverse, just think of that number pi. Well, we'll have some great practice tomorrow. Have a good night.